Welcome to today's webinar, Pie Charts, Bar and Scatter Plots, and Scatter with Regression Plots in FCS Express. In FCS Express, data can be displayed in bar plots, scatter plots, or pie charts that update in real time as you advance through your dataset, or as you change your gating positions or hierarchy. This can eliminate intermediate steps in your workflow, such as exporting and reassembling data in a spreadsheet program and manually generating new graphs for additional data sets or changes in your gating positions. So today we'll go step by step on how to build these plots from scratch. But before we get started, let's just take a look at one or two example layouts so you can see how great these plots can look in FCS Express. This is an example of a T-cell clonotyping experiment where we're looking at different V-beta receptor isoforms here on the x-axis, and on the y-axis we're looking at the frequency of each isoform. So this will update in real time as I move my gates, and you can see if I let the parent T-cell gate come to rest on the T-cell dim population, you'll see we're looking at actually looking at a rather clonal population. So being able to evaluate these gating positions on the fly while you're in the software playing with your raw data is going to be an invaluable time saver for you. Another example of working with bar plots in FCS Express is when you have a whole series of data files that you would like to analyze. So this is an example of quantifying soluble cytokines from culture medium using cytometric bead array kits, and I can go through my data set here and watch the bar plot update for each individual sample. And of course, if I wanted to send out the results in a batch process, I could do so and have exports to PDF, PowerPoint, and Excel all at the click of a button. New in FCS Express is the ability to look at pie charts, and these work in very much the same way as bar plots and scatter plots, and they just give you a nice, interesting new way to look at your data. So for today, we're going to be going through each type of plot and how to build it in FCS Express and format it to your specifications. And hopefully what you'll get a sense of is that the procedures for working with each kind of plot are very similar. So once you learn how to make one kind of plot in FCS Express, you're well on your way for looking at other kinds of plots. Okay? So to start off with, we're going to be learning how to add data to plots, and this is very easy in FCS Express 5. We've added the ability to do that via drag and drop, and that was at customer requests. So a lot of you wanted to work with bar plots but wanted to streamline the procedure for doing so. So we listened and we've put in the ability to add it by drag and drop. You can still do it the old-fashioned way via custom data grids. And if you take a look at this portion of the figure here, you'll see that bar plots and pie charts can be populated both ways, via drag and drop or custom data grid, whereas scatter plots still require working with custom data grids. And that's just because of the nature of scatter plots being a truly bivariate plot. Okay? Secondly, we're going to look at how to display additional data sets. And that's possible to do in all three kinds of plot. So bar plots and scatter plots, additional data sets can be displayed as traditional overlays, and you're already used to working with overlays most likely because you've done that with histograms and other basic 1 and 2D plots in FCS Express. And pie charts can display one additional data set, and that's basically as a ring at the periphery of the pie. Okay, so we'll learn how to do that together. We're also going to be learning how to customize the appearance of bar plots, scatter plots, and pie charts via special formatting options. So you can define the colors of your bar plots or pie charts or scatter plots. You can change the style, however you want it to look for your publications or posters or what have you, you can do in FCS Express. We're also going to learn how to emphasize data according to criteria that you define. And if you take a look here, you'll see that that's possible in all three types of plot as well. So with bar plots and scatter plots, We can highlight a certain bar or a certain point on your scatter plot if that data point meets a criteria that you define. So for example, if you have a bar plot and you want the bar to take on a specific color, such as bright red, if that bar is above 20% or something like that, we can do that. Pie charts, we can also emphasize data, and that's via explosion of the slice away from the pie. Okay, but the procedures for setting this up is identical for each type of plot. We'll also learn how to graph replicates with error bars. Okay, and you see that that's possible both in bar plots and scatter plots. Okay, and lastly, we're going to learn how to use scatter with regression plots, which basically fit a model to your data and overlay the best fit curve on your plot with just one click. So scatter plots and regression analysis was possible in version 4, but in version 5 we've made it much easier to work with, so we hope that you'll take advantage of that. So let's get started with bar plots. So this is a very simple layout, and we're going to put in a bar plot simply by coming to the Insert tab, and you'll see bar there in the 1D plot section. We'll place that on our layout. And we're going to populate this by drag and drop because that's new in version 5. So I'm going to simply grab a gate, drag it over, select a stat, okay? I can also grab statistics from default statistics windows or from tokens that reside elsewhere on your layout, such as in tables and the like. So I'll grab this one over, drop it in, okay? And lastly, let's grab this one. So I could actually replace a bar if I wanted to. I'm going to undo that because I really want to add this in as a new bar. To make overlays, you simply need to grab a statistic or a gate. So I'm going to grab my gate 3 and drop it below the axis. And then it comes in as an overlay. Let's grab this one and put this in as the second bar. And you see we have these handy guides for insertion as well. Another way to make overlays is by overlaying one bar plot onto another. So I'll insert a second bar plot. It comes up empty. And let's put in our gate 4 stats into this one. Okay, so now basically on this bar plot at left, I have the gates 2 and 3, and on this bar plot, I have gate 4. I'm going to grab this bar plot and overlay it onto the original one. All right, and now I'm looking at all 3 gates on that same bar plot. We can format this by coming to Format on the pop-up menu. All right, and let's put in a legend, so we know what we're looking at. We can come over here and type in a descriptor so that the legend makes a little more sense. And we can even color code each overlay so it matches the gates. So let's give this first one, which was gate 2, a blue color to match this blue gate. We'll give the second one a green color to match the green color of gate 3. And we'll give the last overlay an orange color to match the color of gate 4. Okay? And there's even more options. You can customize the appearance of this bar plot by changing the bar color or changing the fill pattern, so you can add in these diagonals. You can even change the bar shape, so rather than the traditional rectangle, you can change it to arrows or what have you. Okay, and of course you can also label these axes so they make a little more sense. So, and that's done simply by clicking on them. And now we can type in some free text, drug 1, sample 1. Okay. You can also click on T for token and add in a keyword token. So these drug 1, drug 2, and drug 3 plot titles are actually encoded as keywords that were saved at the time of acquisition of these FCS files. So I'll just scroll down to that sample ID keyword and put that in. And that's handy to do if you might be using this layout over and over again and you don't want to have to type in free text every time you load in new repetitions of the same experiment. Okay? So that is formatting bar plots. And of course, all the regular formatting elements are here for this plot as well. So if you wanted to change the title or change the axis labels here, you could do that as well. Okay? So let's put in a pie chart with this same data. So I'm going to put in a pie chart, again from the Insert tab. And basically a pie chart comes up showing the same kind of data that's here. But let's build one from scratch. So I'm going to put in this pie chart here, and it comes up empty. And let's delete this one so it's out of the way. So again, pie charts are going to work very much like bar plots in that they can be populated by drag and drop. So I'm going to drag my gate 2 over. And we'll drag in our gate 3. And finally, we'll drag our gate 4. This time we'll just drag the stat directly from the table. Okay? So this pie chart can be formatted with different colors and styles as well. So before we do that, I'm going to introduce you to the custom data grid because that's actually what we need to look at in order to change different formatting elements of this pie chart. So while the pie chart's highlighted, you can insert a data grid from the Insert tab, okay? And you see basically the statistics are here. If we wanted to find the color of the pie chart, we're going to have to add another column to this data grid telling the pie chart what color each slice should be, okay? So before I do that, let's just take a look at the other formatting options for the pie chart. So the color parameter, that's where we can define what color we want each slice to be. But you can also play with different things like color schemes. So right now it's on default. There's different color schemes available, such as Excel, Classic, what have you. Okay? You can choose to show the pie as a donut. Okay? And you can change the caption style. So right now we are showing the value of each slice. I'm going to take that off and instead put in the percentage. You can put the percentage and the name. Okay? So let's put this as name. Okay. And we can actually click on this to add in a descriptor here, just like we did with the bar plot. So I'll type in gate 2. Okay. This is going to be gate 3. All right. And let's put in that extra column here so we can define the color of each slice. And we'll give this column a name color. So here we can start typing in, certain colors are recognized by free text. So we can type in blue. Okay. Let's just come in back into the formatting menu and tell the pie chart where to derive the color. So we will derive the color from the color column that we're setting up right now. Okay? Gate 3 is green, so we'll type in green. Or you know what, let's get the exact shade of green by using this color picker right here. Okay? And you can also use a gate token. So if I want the color of this slice to match the color of the gate it's derived from, I can choose a gate token, gate color. Okay, and there it is, light orange. So there's a few other things you can do to format your pie chart, and we'll go over some of those a little bit later. But I'll just show you, you might want to add in a legend as well. And this works the same as a typical plot. It's here in the legend category. Okay. You can change the size of the donut. So just take a look at the overlays category and you'll see that there's a whole lot of different options for making your pie chart look the way you want it to look. So that is building pie charts with one data set. I'll show you, you can also add in a second data set, and that is again by drag and drop, but we're going to have to drag and drop into the custom data grid, okay? So right now we're looking at gates 2, 3, and 4 from this first sample up here, this drug 1 sample. Let's look at the drug 2 overlaid as a ring around this pie chart. So we're going to drag it into this column that's already generated. Okay. Oops. So we'll drag our gate 2. There we go. And then our gate 3. And our gate 4 stat. And let's come back into the formatting menu and just tell the pie chart which column of the data grid it should derive that ring column from. So right now, the ring parameter is not defined. So we're simply going to choose it from the drop-down. Okay, and there you see the ring has been added. So now, of course, as we move our parent gate around, both of these plots are going to update in real time, and we can even advance through our data set, like I showed you before. Okay, let's take a look at building scatter plots. So we'll use a very similar layout for that. This is almost the same. It's just a little bit different, and you'll see why in a moment. So in order to insert a scatter plot, we need to start out by inserting a data grid. Okay, and let's just give each one of these a name. So we'll make the x-axis of the scatter plot be the treatment time in hours. Because as you can see at the top of each plot, the titles, each one of these plots represents a different treatment time. So that's what we'll be looking at on the x-axis of the scatter plot. And we're going to look at the gate 2 populations to start off with. And let's also look at the gate 3. So we'll enter in the treatment time now. And one thing I'd like to point out, the differences between bar plots, pie charts, and scatter plots. In scatter plots, your x-axis values must be numeric, okay? So those are truly 2D bivariate plots, so you can't have categories here in the x-axis. They need to be actual numerals. All right, so let's drag and drop the statistics from gate 2 from each time point into the data grid here. All right, so now I can insert a scatter plot from the Insert tab. Okay, and we can of course format this, but let's do something more interesting. Let's make another overlay. So I'm going to grab my gate 3, put it into each column, each row of the gate 3 column. Okay, and now to make an overlay, I can simply drag my data grid into the scatter plot. And we can now start formatting this scatter plot. So, right now, both this first overlay and the second overlay are deriving the y parameter from gate 2. Okay, and that's why both of the points look the same. So let's change the second overlay to derive the data points from the gate 3 column. Alright, so now you can see that the scatter plot is displaying data from both columns. And again, just like we formatted the bar plot, we can do the same thing here with the scatter plot. So I can change the point color of gate 2 to match the color of gate 2. And the second overlay corresponds to gate 3, so we'll make the point color green. Okay, and of course there's lots of visual elements that you can play with here in FCS Express. So if you want to change the point shape from rectangle to triangle, you can do so. You can increase the size. Okay, there's different point fill styles. Oops. Okay, so there's a whole lot of different things. You can even connect the lines if you're trying to tell a story. So there's really no limit, and of course all the regular formatting options are here as well. So we can call this our scatter plot for treatment time effect. Okay, so, and of course you can change the axes labels. So right now the axes labels are being derived from the column titles of the data grid, but you can change the titles by simply coming to the axis category and typing in some free text with the specified text below option. So we'll call the y-axis %, and let's call the x-axis just simply time. Okay, and just like the other plot types, these will update as you change your data or as you change your gates. Alright, so now let's take a look at some of the other options we talked about. So remember, in addition to building plots and displaying additional data sets and customizing the appearance, the color, style, so forth, we can also emphasize data according to user-defined criteria. So that's kind of handy if you want to call attention to data points of interest. And a good example of that can be shown with this pie chart layout right here. So this pie chart's already been built. Let's take a look at the data grid that was automatically generated after the pie chart was built by drag and drop. And you'll see that we've already defined a column here of the data grid called emphasis. So I'm going to set up the emphasis criterion, which in the case of a pie chart is the explode criterion for the debris. Okay, and before I do that, I'll just show you that in order to have that function on your pie chart, you need to make sure that the explode parameter is set to the column of the data grid that you intend. So here, I'm going to type in equals, and we'll enter in a token for the debris. So we want, let's say we want the debris slice, which is this aqua slice here, to explode away from the pie if its value is greater than 7%. So we'll put in a token for debris. I'll type a greater than sign, 5. Okay, so right now it's greater than 5%, so it's exploded away from the pie. I can move this around, watch it update, and if I move this debris to a position where right now it's just 2%, you see that it's not exploded. So that's going to dynamically update. And this works exactly the same way for bar plots. So let's put in a bar plot of the same data. Okay, and right now it's not, the bar plot, the bar for debris is not highlighted, but that's simply because, again, we have not set up the column to derive from the emphasis channel. So I'll just come here to the highlight parameter. So emphasis in bar plots is called highlighting, whereas it's called exploding in pie charts, but it's the same principle, it works the same way. So we'll just set that highlight parameter to emphasis, and you can see that there it's been emphasized in light blue. Of course, you can change it to a more eye-catching color like bright red. Okay, so that's how emphasis works for pie charts and bar plots, and that's via explode or highlight respectively. Let's take a look now at how to graph replicates with error bars. So a lot of times in experiments, you're not looking at a single sample, but rather you're looking at replicates of samples, and you want to graph the mean and the standard deviation perhaps as error bars, okay? So this is an example of a layout with 3 different replicates, and they're shown here at the top, replicate 1, 2, and 3. And we've already built a bar plot, and the mean is being displayed for the 2 gates, APO and necro. All right, so let's take a look at the data grid. So remember, when you're building a bar plot, you need not to access the data grid, but to add in these special formatting options like highlighting and error bars, then you do need to open up the data grid. And this data grid has been automatically generated from the bar plot after it was populated by drag and drop. So right now, you can see we already have the means graphed of the APO and necro populations, or the green and purple gates, okay? And the mean is an array formula. So the mean is being calculated on, for this highlighted cell, the APO green gate for these 3 plots at the top, okay? So what we're gonna do is use the standard dev array formula, which works almost the same as this mean formula in terms of inserting it into the data grid. So we're going to put in a new column for our data grid, and we'll call this our standard dev because this is what we want to graph as error bars. All right, and you can right click and simply scroll down to the stat you want. So we want this standard dev stat, okay? So the syntax has already been put in place. We just need to put the tokens in. So I'm going to highlight this placeholder for the first number and insert a token for this first replicate. And we're going to put in our APO gate, percent of gated cells, okay? And the same thing for number 2. And we're going to choose the second replicate. Actually, let's APO2 gate goes with that one. Okay. And the same thing for the third one. Let's just get rid of these ... So I'm choosing the third replicate. There we go. Oh, looks like I may have lost a parentheses. Here, let's just take a look at the formula. Okay, we were just missing a comma there. So just make sure you don't delete any of those commas. Okay, so there it has updated at 2.86 is the standard dev for the green gate between the 3 replicates. So we can do the same thing for the necro, but I'm going to take a little shortcut And I'm just going to grab the mean here from the mean column, select all this, and we're going to do a copy paste. And in order to save time, because all of these tokens inside the parentheses are correct, I'm just going to delete the word mean here and type in standard div. Okay, there it is. And to get these error bars to display, we'll come into our formatting menu, and in the same way that we told the pie chart and the bar plot where to get their highlighting parameter from, or their explode parameter from, we're going to tell the bar plot where to get the error bar parameter from. Okay, so right now the error bar parameter is defined as do not show error bar. That's why it's not showing up on the plot. All right, so we're going to tell it to get the error bar parameter from the standard div column. Okay, and there it is. And of course you can play with the style of the error bar, make it a little bit thicker, maybe change it to a different color. Okay. And if I wanted to, I could right click and insert more columns if I wanted to add highlighting, a highlighting criterion, or maybe add another column if I wanted to add overlays to this bar plot. Okay, so all that flexibility that we've gone through already is still there for you. So that is working with bar plots, pie charts, and scatter plots. Let's switch gears now and talk about scatter with regression plots. So scatter with regression plots, they'll help you fit a model to your data and overlay the best fit curve on your plot at a click. But something neat you can do in version 5 is actually look at relationships between raw parameters in a scatter with regression plot. So this is an example of an image cytometry file, just to show you the variety of things you can do. And of course you can do this with a flow cytometry file, but let's do this with this image cytometry file for today. This microscopic picture that has been segmented. It's not actually image cytometry file, excuse me. So we're going to put in a scatter with regression plot, okay? And let's just take a look at what the relationship between different parameters might be. So hopefully you can see that we're looking at, on the x-axis, the area of each object, which in this case is a cell, versus the eccentricity on the y-axis. So let's change this to, let's say, perimeter, okay? And we'll double click on the plot, bring up the formatting menu, and you'll see that we have a choice between different regression types. So right now we're looking at linear. We can take a look at sigmoidal, okay? And so you have all the different constants for the best fit line, including the r squared, the goodness of fit. And so that regression line is there showing up in red. Let's just keep this on linear for now, and maybe we'll make the line a little bit thicker just so it's easier to see. Oops. So we'll make this line a little bit thicker. There we go. Okay, and we can even put in a token so we can see all of those regression parameter values. Okay, and we can apply a gate to the sample. So as I move this, you can see that it's updating. Okay, so if you have some interesting multi-parametric files that you want to just kind of take a look and see how the parameters might relate to each other, this might be useful for you. But the more frequent case in which you might use these scatter with regression plots is actually to look at a whole experiment where you want to see the relationship between different variables across your experiment. So let's pull that one up as well. Okay, so this is an example of setting up the standards for a cytometric bead array experiment. So right now we're looking at different cytokines here on the left, and typically you have a limiting serial dilution of each cytokine standard. So for instance, for this IL-2 blue standard, we have different plots here looking at from a 1 to 2 all the way down to a 1 to 256 dilution. And you use those MFIs from each dilution to construct a standard curve from which you'll then interpolate the values from your experimental unknowns. Okay, so this data grid, this custom data grid has almost been completed for the IL-2 column. And let me zoom in a little bit so you can see. There we go, that's probably a little bit easier to see. So we just need to drag in the IL-2 MFI for the 1 to 256 dilution. So I'll just grab this plot and drag it in. All right, and now we can insert our scatter with regression plot. Let's change the x-axis here to the log concentration, which just to show you, this works just like the other plot types we've already gone through, where the scatter with regression plot parameters correspond to columns in the data grid. So this x parameter is we're making it correspond to the log concentration, and we'll change the y parameter to the IL-2 MFI. So this doesn't look like a very good fit, and that's because it has defaulted to linear. So let's come into our formatting menu. And we'll change the regression type from linear to, well, let's just check out different ones and see which ones look good. So that's exponential grow, that looks pretty good. We have an R-squared goodness of fit of 0.98. I think we can do better than that. And I happen to know that this is a 4-parameter logistic fit traditionally, so let's use that 4-parameter logistic. Okay? And again, we can put in those model parameter, the model parameter tokens here as a text box. And we can even put in the name of the model that we've applied to our data. Okay, and of course, just like the other plot types, I can change this gate, which in this case happens to be linked to this IL-2 marker, and watch the regression update in real time. And just to prove to you this is real data, you'll see that the fit is very good, but it's slightly imperfect, just like real world data always is. All right, so hopefully what I've showed you is that it's very easy to work with pie charts, scatter plots, bar plots, and scatter with regression plots in FCS Express, and they update in real time as you move your gates. And so we encourage you to try different plotting options to present your data in the most informative way. You might be surprised what a difference it can make in your storytelling. And I think in the end this will save you a lot of time, because effectively you're integrating the workflow both for analysis and reporting of your cytometry data in the same software. So in closing out, I'd just like to take you to our website. And show you where you can register for some more upcoming webinars. So here on our website, You can always come here to the right-hand side and click on Register Upcoming Webinars. And if you haven't already, we definitely encourage you to download a demo of FCS Express 5 and see how it works with your own data. If you do run into any questions or need any help while you're working with the software, you can always click on the Support tab here in the Startup screen, and that will bring you to this web page where you can click on the first link to schedule live help. So we'll be happy to help you out with your own data on a screen share, or you can send us an email or leave us a phone message, and we'll usually get back to you very quickly, definitely within 24 hours, sometimes much faster. So if there are no other questions, I just want to thank you so much for joining us today, and have a great day.